You ask and you get. That's how it works over here. So there is a lot of comments on YouTube and on Reddit that can we do a tutorial with YOLOv6? Of course we can. Of course we can. I mean, like, it is right now my life mission to keep you guys up to date with all YOLO developments. Before we start the actual tutorial, let me just tell you that we have 2 articles about YOLOv6. The first one goes through the details of the architecture and kind of like what is new in this iteration. From my perspective, the most interesting part is probably that it's anchorless. Before that, I guess only YOLOv6 was designed like that. And the second one is the companion article to this YouTube video, when we go in written form through the details on how to actually train YOLOv6 on the custom dataset. Both of those articles will be linked in the description below. As usual, we also prepared a Google Colab for you guys to have a good starting point for your journey with YOLOv6. So we just open it in a new tab, save copy on our Google Drive, and we are good to start. So the first thing that we are usually doing is obviously connect Google Colab to Python environment with a GPU. So let's start by actually confirming that we have indeed the access to the GPU. So I guess the easiest way to do it is to do NVIDIA SMI, and we should see details of our GPU. That is the case. So we can go straight into the first actual tab of the tutorial and install all the required dependencies. Just after a few seconds, we should be ready to go. There is not a lot of dependencies to install, as Google Colab environment usually comes with most of the deep learning frameworks. So it is always a good idea to run pre-trained model on some example image as the last step of the configuration process, just to make sure that everything has been configured properly. So let's run those 3 cells over here. The first one will download an example image from Coco dataset. The second one will download pre-trained weights. The third one is actually loading the model into the memory and running that model on the example image. And we see that everything has finished without any errors. Over here in the Inference results directory, we see that we have a new image. It looks like everything runs properly. The model has inferred on the Coco image and the annotations are visible. Our Python environment is ready, but before we start, I just want to let you know that, of course, we have a different data structure than in any other framework. So YOLOv6 team decided to change it a little bit. They are still using YOLO.txt files, but organize them in the subdirectories for labels and for images and for train, test, and validation sets. So it's all a little bit convoluted, but everything is described in the Google Colab, so make sure to take a look. We are, however, using a dataset that is accessible at Roboflow Universe, so we don't need to be really bothered with those structuring details. One of the greatest things, I guess, about the Roboflow Universe is that you can get the dataset in any of accessible formats, and we are basically supporting like any major computer vision framework right now. I'm just switching the version of the dataset from raw to augmented, as I hoped it will get us a little bit more accuracy at the very end. So we are just selecting YOLOv6 format and click continue. That should generate a code snippet that we just copy and paste into our notebook. Now I can just paste the snippet over here and press enter, and the dataset is basically being fetched to my local drive so that it will be accessible during the training process. We are using the Roboflow pip package, so there is a little bit of installation at the very beginning before we start to download the dataset, but still it is pretty smooth integration. By the way, if you are interested in using augmentation to make your dataset larger and hopefully your model more robust, take a look at the video done by Jacob. He will take you through all the steps. One of the great things about YOLOv6 is that it supports multi-GPU training out of the box. So if you have access to this kind of hardware, it may be a great option for you. Today, however, we are doing a free training on Google Colab, so one GPU must be enough. So over here, we provided a little bit of background on how to actually run the multi-GPU training, but let's just scroll by that and go straight to the cell that is actually responsible for our training over here. So we've selected some default arguments like batch size of 32 and epochs 100. And we are passing the data YAML that is actually coming with the data set from the Roboflow Universe. So we just press enter over here and the training can start. So our model is training. So I decided we have a little bit of time for the hot take. So my question is there anybody over there who knows which YOLO-based model is actually the best one? Because I'm going through the readmes of those projects and I'm honestly confused. YOLOv6, higher accuracy than other detectors with similar inference speed. And they even have a chart, latency versus average precision. And it's quite clear on the chart that they are better than even YOLOv7 over here. But on the other hand, when I go to YOLOv7, they say state-of-the-art real-time object detector. And they even get a badge from Papers with Code saying that they are the best on Coco dataset. And on the chart, latency versus average precision, they have like this gigantic arrow saying plus 120% faster. So I understand that it is hard to assess that because there are multiple versions of those models and each of them has different parameters, different latency and different accuracy. But if every model is the fastest and the most accurate, then which model is the fastest and most accurate? We will definitely need to do a video about it. Training is done. We can now jump into the evaluation and inference stages. So over here, we can trigger the evaluation. Similarly, like with YOLOv5 and with V7, we have separate script to train, evaluate, and infer. We are using our validation set that contains 58 images. And we can now take a look at our metrics. I would say quite average results for average precision and recall. But you know, the model could be trained longer or with larger data set. So the last step of our tutorial is actually to run our freshly trained model on images from the test set. So we assembled a Python command to do that. It loads the model into memory and runs it on all 29 images. And the last thing that we can do is actually visualize the results coming from Inference. So that cell is basically taking all the images present in the Inference result directory and plotting them on the screen. And we can confirm whatever we felt after the evaluation stage. The model could be better. There are some objects that have not been detected. And there are some false positives or double detections like over here, where the model is not certain whether or not it's black king or black rook. Certainly, we could do a better job with more iterations and more images in the dataset. And that's it. I hope that you have right now a better understanding of YOLOv6 model. You can judge by the view behind my window that it took a little bit of time to record the video. So if you find it useful, make sure to like and subscribe. And stay tuned for more computer vision content coming to this channel soon. My name was Peter. Bye.